Welcome back to day number 5. Our goal for today, given a system of inequalities, you will be able to graph them and answer questions about the graph. All right, so before we get to graphing inequalities, let's just review simply graphing of our lines. So real quick, remember, graphing lines, the equation of a line is typically in the form y equals mx plus b. This is called slope-intercept form, and the reason it's called slope-intercept form is because the m stands for your slope, and your b stands for the y-intercept. Okay, so the way that's going to work, if you're told to graph y equals -1/2 x plus 3, that means you're going to start at your y-intercept. In this case, it's going to be +3. And then you're going to use your slope. So your slope is -1/2. So down 1 to the right 2. Down 1 to the right 2. And then you're going to simply just connect your dots. And you've got your line. Always remember, we want to label our lines at one of the arrows. Okay, so this is a diagonal line. It can be diagonal negative slope or diagonal positive slope. We can also have horizontal lines. So remember, a horizontal line goes straight across your screen. When you have that, your slope is equal to 0. And your equation is always going to be y equals a number. So there's no x involved because there's no slope. The slope is 0. So for instance, here we have graph y equals 2. So I'm going to go on my y-axis and I'm going to go up to 2. And this is going to be a horizontal line. So I'm going to go straight across my graph. So y equals 2. Okay, next up, we have vertical line. So vertical line is straight up and down. Now a vertical line, its slope is undefined. And the reason its slope is undefined is because a line going straight up and down, it is not a function because it fails the vertical line test. Its equation is x equals a number. So for our example here, graph x equals -1. So on the x-axis, I'm going to go over to -1, and I'm going to draw a vertical line that goes straight through that value. So this is the line x equals -1. Okay, now that we've reviewed graphing lines, let's review graphing our inequalities. So remember, an inequality is an entire set of numbers that go with a distinct value of an inequality. All right, so a couple kind of notes here. Remember, we've done this a couple times already this school year, so this is just a quick review of it. If you want to have a dotted line, that means you're going to be less than or you're going to be greater than. But there's going to be no equal to symbol here. So you're not allowed to be equal to the line. You have to be greater than it or less than. To have a solid line, it's going to be less than or equal to or greater than or equal to. And I should go ahead and put there's a y here. So these are y's. So y is less than or equal to, y is greater than or equal to. Now this is a solid line because this time, yes, you are allowed to be on the line. The line counts. Next up, if you're going to shade up, that means your y is greater than or your y is greater than or equal to. So shade up means greater than. To shade down, your y is less than or your y is less than or equal to. All right, so let's go ahead and let's practice graphing a system. All right, so if we take a look at our very first one, the first thing we need to do is get the y by itself. So I'm going to go ahead and divide everything here by 2. So now I have y is greater than x minus 3. So there's my first inequality. Now, if I look carefully, y is greater than, so that means this is going to shade up. So shade up, and there's no line underneath, so that means it's going to be a dotted line. Okay, let's take a look at the next one. So over here, again, we want to get the y by itself. So the first thing I'm going to do is I'm going to subtract the x to the other side. So y minus 5 is less than or equal to -x, and then I'm going to add the 5 over. So now I get y is less than or equal to -x plus 5. There's my equation. Now y is less than, so that means we're going to shade down. And this time we have the equal to symbol underneath. Oops, let me shift this over a little bit. So that means we are going to have a solid line. Okay, so let's go ahead and let's try these. So I'm going to go for the first equation first. So y is greater than x minus 3. So I'm going to start, so here's my x-axis and my y-axis. So here's 0, 0. There's my origin. So I'm going to go down to negative 3. And there's my first point. Now my slope, if there's no number in front of the x, your slope is a 1 over 1. So I'm going to go up 1 to the right 1, up 1 to the right 1, and all the way across. Okay, once you have a bunch of points, now we can use our rulers to draw our line. Now in this case, it's going to be a dotted line, so I want to make sure that I make it very distinct so the person, anybody that looks at my paper would know that this is indeed a dotted line. At one of the arrows, I'm going to put y is greater than x minus 3. Now, I want to shade up. Now, shading up means my y-axis, I want to go to positive infinity. So for this one, I'm going to shade up to positive infinity. It's greater than. Now I'm going to look at my second equation. This time I'm going to start at the positive 5. So on my y-axis I go up to 5. 1, 2, 3, 4, 5. And this time my slope is a negative 1 over 1. So I'm going to go down 1 to the right 1. Okay, and once I have a few points, I can go ahead and graph it. Draw my line. This time it's a solid line. All right, so if we take a look here now, I'm going to write y is less than or equal to x plus 5, negative x plus 5. All right, now this time my y is less than, so that means on my y-axis I want to shade to negative infinity. All right, so that means I'm going to shade downwards towards that negative infinity. Okay, so now we've graphed our system. So now we have to answer some follow-up questions. Label the solution set as A. So here's my big A. The solution set is where we shaded twice. It is for both of the inequalities. State one point within the solution set. So I want to pick any point inside of here. So I'm going to go ahead and pick negative 6, 1. Now, state one point that makes neither inequality true. That means neither of the inequalities is shaded, so that's the unshaded region. So I'm going to go ahead and just pick 10, 0, and then we've got it. So be very careful. You don't want to pick a point for your solution set that's on the dotted line, because remember, dotted lines do not count. All right, it's a very nice job so far. Let's go ahead and flip it over. All right, so now we've got ourselves a handy-dandy little real-world application problem. All right, so the Real Good Cinema is conducting a mathematical study. In its theater, there are 200 seats. If adult tickets cost $12.50 and child tickets cost $6.25, the cinema's goal is to sell at least $1,500 worth of tickets for the theater. Write a system of linear inequalities that could be used to find possible combination of adult tickets X and child tickets Y that would satisfy the cinema's goal. Graph the solution to this system of inequalities on the axes below and label with an S. Marta claims that selling 30 adult tickets and 80 child tickets will result in the meeting of the cinema's goal. Explain whether she is incorrect or incorrect based on the graph. Okay, there's a lot going on here, and inside of this question, there's actually 3 different questions. There's write the system, graph the system, and then is Marta correct? So there's 3 parts. So let's start with the first part, which is just write out the system. So to write the system of equations, it's telling me that X is equal to child and Y is equal to adult. Now remember, if there's 2 variables, we need 2 equations. All right, so let's look for our first piece of information. The first piece of information is there are 200 seats. That means X plus Y, can it be greater than 200? No, it cannot. So X plus Y has to be less than or equal to 200. You cannot sell more than 200 tickets. All right, now let's take a look at our second one. So our second equation is going to be money, money, and money. Money, money, monies! All the monies are going to go together. So let's go ahead and put this together. Adult tickets cost $12.50 and child's tickets cost $6.25. So let me make sure, did I set this up right? Adult tickets X and child's tickets Y. Oh, look at that, I goofed around. So let's go ahead. It says adult tickets are your X and child's tickets are your right. I misread it, I apologize. But it doesn't change our first one because it's just adding. But our second equation, it's very important because $12.50 is adult, that has to go with our X. Okay, our child's tickets has to be with the Y. And we want to sell at least. That means we want to sell more or equal to $1,500. All right. So now we've done the first part of the problem, which was to write a system. So now that we have our system, now we want to graph it. So remember, in order to graph, we have to get the Y by itself. So I'm going to take my first equation. All right, X plus Y is less than or equal to 200. I'm going to subtract X from both sides. So this is Y is less than or equal to negative X plus 200. All right, so I'm going to go ahead and I'm going to graph that. So I'm going to start at 200. So here's 200. And now I'm going to go down 1 over 1, down 1 over 1. All right, once you have a couple of points, we can go ahead and we can graph this. Now it's less than or equal to, so that means it's a solid line. All right, and if we want to be less than, that means we're going to shade down. All right, so now let's take a look at our second line. So our second line is 1250x plus 625y is greater than or equal to 1,500. So I'm going to subtract the 1250x. I want to get the y by itself. So 6.25y is greater than or equal to negative 12. I always want to put my x first, plus 1,500. Oh, I'm sorry, you can't see that. I'm going to move that up. Okay, so now we're going to divide everything by 625. I'm trying to get the y all by itself. So now we have y is greater than or equal to, and now I can, in my calculator, type this in. Oops. So negative 12.5 divided by 6.25, and we're going to get negative 2x plus, and now let's go 1,500 divided by 6.25, we get 240. So now let's graph this line. So for this line, we're going to start at 240, which is a little bit higher up. Okay, and now we're going to go down 2 over 1, down 2 over 1. Okay, and I'm going to follow through with this all the way down. And now I'm going to graph my line. Okay, and once again, this can be a solid line. And this time, we want the y to be greater than, so we need to shade above this line. All right, so our solution set is going to be right here. So now we've answered the second part of this question. First part, write the equation. Second part was to graph. Now we have to check to see if Martha is correct. So let's go back up and check it out. So Martha is claiming that she can sell 30 adult tickets. So 30 adult, remember adult was our X. So 30 would be our X, and 80 child's tickets. 80 for the Y will result in meeting the cinema's goals. Explain if she is correct or incorrect. So let's take a look. 30 and 80, let's see if it works. Over 30, up 80. So this is where Martha is. Is Martha correct? Well, I would say no. Martha, I should say Martha's point, is not in the solution set. That's one way to do it. The other way to do it is you can take the 30 and the 80 and you can plug them into both equations to see if it works. But just saying it's not in the solution set would work as well. All right, great job everyone for today. Now what you're going to do is you're going to flip the page over and you're going to try this last question on your own. Have a great day everyone. I'll see you in class tomorrow.